Thank you, Mr. President. Good morning to everyone. Gracias, señor secretario autonómico, por estar con nosotros. Señor Schulz, Dr. Morsi, it's a pleasure to have you here, all of you. And it's a pleasure for me, as director of Valenciaport Fundation, to have the opportunity of sharing with you this Greencranes Valencia Demo Day. Thanks to all of you for being here, especially to those of you that come from out of Spain. We hope that all the information, the experiences, and the real pilots that you will see during the day will make it worthy in here. Okay. My objective for the next few minutes is to lead you through a quick presentation, a quick overview of the Greencranes initiative, this 10T 50% co-founded project exploring into concrete solutions on the application of green technologies and this concept of eco-efficient alternatives for cranes and operations at port container terminals. This overview will help you to understand and to put into context the pilots we are going to see afterwards and the ones that will be presented also in the next days in Koper and Livorno. So on this quick overview, I will mention some key aspects of the objectives of the initiative, the main activities in which we have been working for the last year and a half, 2 years, and the results that we have arrived at, and the communication tools that the team is using to disseminate the generated knowledge, and as this Valencia Demo Day that we have just started. So, going on, the project overview. This Greencranes project is a 10T market-sided innovation project integrated by 7 partners from 3 countries, from Slovenia, Italy, and Spain. The project is coordinated by Valenciaport Foundation, being also involved the Port Authority of Valencia, Noatum, the Port of Koper, and the port equipment manufacturers, Greencranes and AVMV, between others. The Italian Ministry of Infrastructures and Transport is also involved, and they coordinate the 4 implementation bodies, the Port Authority of Livorno, RINA, the Scuola Superiore Santa Ana de Pisa, and the industrial company Global Service. Our objectives on this project, the main objective of Greencranes, is to demonstrate the feasibility of implementing these selected eco-efficient options based on the use of alternative fuels and smart energy management at port container terminals in Europe. These eco-efficient alternatives can be the starting point to facilitate the evolution of the port sector to a low carbon emission model in line with the objectives of the European Commission. So, Greencranes is structured into 3 technical activities. The first one was oriented to define the energy consumption profile, the energy consumption profiles of the 3 terminals involved, in order to set the basis scenario for the further studies and evaluations that have been developed in Activity 2. And Activity 3, that is now running and concerns the development of the pilot projects that you will see, of those alternatives with best impact in terms of investment profitability and emissions reduction. So Activity 1 developed 3 energy diagnoses in the 3 participant terminals. The objective was to answer 2 apparently easy questions, simple questions. How much energy is consumed in the container terminal, and where is this energy consumed? So the study developed in this activity started with the classification of the different elements, the different energy consumers centers or assets in the port container terminal. We can distinguish these 2 main groups that you are seeing, depending on the source of energy, electricity or fuel. In the first case, the first line, the equipment involved are the ship-to-shore cranes, the reefers, which are plugged in the yard terminal, the offices, and the lining. If we look at the second row, the fuel consumption, we find mainly yard vehicles in charge of moving containers inside the terminal. The RTGs, the terminal tractors, the reach stackers, and the empty forklifts. So in this slide, we can see the results corresponding to the electricity consumption at the 3 container terminals studied in aggregated values. We can define a ranking of consumption starting from the reefers and following with the ship-to-shore cranes. These 2 categories amount around 80% of the total electricity consumption, and this percentage is quite similar in the 3 terminals. The yard lighting and the offices are minor consumption centers in comparison with these 2 first categories. And then if we look if we consider the same approach when talking about the fuel consumption, the aggregated values of fuel consumption, you can see there, the aggregated values of the 3 terminals rank in first position the RTGs with almost 60% of the consumption, of the total fuel consumption. The yard tractors is the second category with more than 30%, and finally the reach stackers and the empty container forklifts complete this 10% remaining. An important conclusion here, in the same way as the previous slide, is that these 2 types of machines, the RTGs and the tractors, are responsible for the 90% of the fuel consumption at port container terminals. In the last line, you can see in terms of CO2 emissions, just to have a reference, this weekend the public transport system in a city as Brussels, the STIB, that Helmut, you know well, the public transport in Brussels, published, they including the metro, the train, the trams and the buses, and Brussels is a city of more or less 1 million people moving, and their CO2 emissions last year was in the range of 62,000 tons in the year. If we consider these figures that we showed here, the 4.15 and the 7.57 kilos of CO2 per TEU, we are in the range of 5.3 million TEUs is the equivalent to a city of 1 million people moving. So we are talking about big things in ports, big things that have to improve. After we go to activity 2, after establishing the base scenario for assessing the alternatives in activity 1, activity 2 consisted in the evaluation of a group of selected eco-efficient alternatives that you can see in the screen. The LNG implementation in terminal tractors that was studied here in Valencia, in Oatum. The study of eco-fuels for rich stackers retrofitting, mainly studied in Livorno. Electrification of the RTGs, here also in Oatum. Application of flywheel technologies in RTGs that was analyzed in copper. And the implementation of energy management systems based on international standards, like the ISO 50001 norm that was studied and developed. You will see a video on this in copper. Each one of these alternatives has different possibilities. For instance, inside the electrification study, 2 technologies were evaluated, the cable reel and the conductor bar technology solutions, and just only those solutions with high potential of market adoption have been tested in pilots like the 2 that we are presenting today. So this is why it's important to be aware that we are in the market sided and the financial things are basic to this. So in order to study the feasibility of the Greencranes alternatives, we developed a financial model that was designed in order to calculate the basic parameters, the net present value, the internal rate of return and the investment payback. And this model has been applied considering different real business cases of the 3 terminals. So it was adapted for each one. In the case of Noatum, the model was applied to a set of business cases that you can read on the screen, related to the use of container yard machinery, the RTGs and the terminal tractors, the main fuel consumers, as we have seen in the previous slides. I'm not going into the details of the model, but for example, in the case of terminal tractors, the model applied considers more than 20 variables from different aspects of the yard machinery management, like energy consumption, machine assignment rules, maintenance, and so on. And with these inputs, the model provides the minimum number of diesel vehicles to be replaced by new LNG units to make the investment feasible. It is also possible to calculate the fleet, which makes maximum the internal return rate of the investment and the potential decrease of greenhouse gas emissions. It's also to be said that along the process of developing this model, other concrete lines of potential improvements were identified by the technical groups and studied in parallel to the Greencranes activity. In the case of the RTG electrification, the same approach was carried out, considering the two alternatives. So in electrification, the cable reel and the conductor bar technologies. And the study concluded that the investment needed to deploy infrastructure at the terminal for electrifying these RTGs was too high, therefore resulting the project not viable. In this manner, then other alternatives were evaluated, like the implementation of LNG as a fuel for RTG cranes, and the retrofitting of the genset groups of the cranes in order to optimize and adapt the power of the machine to the yard operations. This option was finally the one with greater possibilities of market adoption from the technical, from the financial, and the environmental perspective. So, for these reasons, we are today presenting these two main results of Greencranes here in Valencia. On the one hand, we will show how an existing RTG can be equipped with a low power genset and keep performing operations with the same degree of reliability. And after that, we are very proud of presenting the first European port term effective market-sided innovation conducted with this equipment, from the design and the manufacturing process to the deployment in a real scenario, the Livorno-Darsena Toscana at the port of Livorno. In the same manner, the Port of Koper will present in just 10 days, the 12th of December, the results of a very challenging pilot project also, based on the implementation of an energy consumption monitoring system in line with the ISO 50001 standard. And we kindly invite those interested to attend also to those demonstration days. Now we have a quick video from our colleagues in Koper that we can show about this system.
Greencranes is a TENT action co-financed for 50% by the European Union, through which the company Luca Koper implemented a prototype of real-time energy consumption monitoring system at the container terminal of the Port of Koper. Based on measurements of energy consumption and energy factors, the prototype aims at increasing the knowledge on energy employment, but it enables also setting up specific KPIs together with accountability system. The system will also provide a feedback after any planned change in production and force responsible people to constantly follow the target values. The activity consisted in 4 steps, where the energy consumption units were selected as representative and significant samples. Installation of measuring and communication devices on 17 spots, including shore cranes, reefer electrical outlets, light towers, the terminal gate, and administration offices to monitor electricity consumption on a representative group. Installation of measuring and communication devices on 4 terminal tugs, 2 reach stakers, 2 empty handlers, 2 RTGs to monitor fuel consumption. Upgrade of the information system of 7 Greencranes RTGs to be able to separate false movements from the targeted actions. information integration to support the creation of a real-time monitoring system of energy management.
So thank you very much to our colleagues in Copper for the video. And just to end my presentation, the results, I think that the main result is that Greencranes has demonstrated that it is possible to introduce alternative and cleaner fuels in the port sector and the port operations. This objective is aligned with the strategy of the European Commission regarding the evolution of low carbon emissions model, recently encouraged with the release of the Clean Power for Transport package. With Greencranes, our aim is to contribute to this process, making the port sector more competitive and sustainable. So to know more about it, if you want to know more about the project, you can visit the web page. You have the web page. You can also participate in our group of LinkedIn and in Twitter as well. We are developing debates and building a network in order to increase the awareness about the importance of introducing this energy efficiency approach within the European ports. And finally, to summarize, Greencranes represents a successful case of collaboration between public and private entities, between business and research and innovation organizations, aligned with the European Commission policies in order to decrease energy consumption and greenhouse gas emissions at port container terminals by introducing the green technologies and the eco-efficient alternatives in our operations. We now see the need to continue pushing for the definite design of the selected alternatives, for the extension of the use in other ports and terminals, and the identification of new eco-efficient alternatives regarding different elements of the whole port logistics chain. So we thank all the participants' efforts, and especially the European Union Commission for the continuous compromise and involvement, hoping that this will go on in the next projects and initiatives. Thank you very much.